So Wärtsilä is a multinational energy company. We're based in Helsinki in Finland, listed on the Helsinki Stock Exchange, and we provide energy solutions to the energy sector. Our interest in South Africa is predominantly in the upcoming gas to power program. We've done a project in Sasolburg for Sasol. That was a 180 megawatt gas-fired power project. We did the turnkey construction and operations and maintenance for that project. Well, if South Africa wants to reach their goals of becoming a more sustainable energy power provider in the future, that inherently means more renewable energy. And to support an increasing renewable energy base, you need something to support that intermittency provided from the renewables. And that's where gas plays a big role in balancing and supporting the South African power system of the future. So gas technologies, the benefits of gas technologies is that they are fast starting and highly efficient. And because you can turn on gas technology very, very quickly, you're able to balance the sudden variations caused by the wind dropping or the sun increasing or a cloud going over a plant, etc., etc. And it does it much more effectively than, say, for example, a coal power station or more traditional thermal power station. Well, as Wärtsilä, we are a provider of internal combustion engine technology, and the startup times that we're able to provide to the system is we can provide any load full output within 5 minutes, which is needed and becomes very important when you're talking about very sudden changes from the renewable outputs. And the quicker, the better, and the more accurate you can meet the supply-demand variation, the better it is from a system reliability point of view. Well, typical, say, Ankerlig would take, on average, maybe 20 to 30 minutes to get to full load, and a coal power station would take a couple of hours to get to full load. And then on top of that, you do have additional costs incurred every time you start up these different technologies, whereas with the engine technology, it is on and off all day and without any extra cost implications. And having that security that there's no additional expenses is very important when you're talking about uncertainty balancing in the power system. There's zero impact. So it's think of like your car engine, your more modern cars. At every robot, the engine is turning off, but that doesn't incur additional maintenance. It's the same for a power plant. No additional costs incurred. From a conceptual level, we agree with the fact that they recognize a stronger renewable and gas mix. So we support that aspect. As to commenting further from that, it's very difficult to comment without having more inputs and more information provided. So we will be providing comment on as a technology provider into the IRP, and we are very pleased about the fact that Engine Technology is now a modelled entity in the IRP. However, we do have some comments on those inputs, which we will be making in the public presentation soon. We're looking to be one of the legs of the consortia, which is the power plant operator. So we have experience in building these power projects all over the world, and we are able to bring an integrated construction LNG terminal plus power project to a consortium. So we're definitely looking to be part of a consortium, and we are naturally in discussions with various parties out there. Gas from LNG will generally be more expensive than your more conventional technologies such as coal. But the role of gas, if it's supplied from LNG, it will generally remain the same. So you've got to remember that your cheap power is coal traditionally, and your most expensive power is diesel. And so long as gas sits in between that large bracket of expensive diesel and cheap coal, So whether the gas is $15 or $10 a gigajoule actually makes zero difference from a system operator perspective. And the important thing is that the gas gets the flexibility it needs. Whether that costs a little bit more from the gas side, well, so be it. The benefit is through the flexibility, not through reducing the gas molecule price. The end user will see the benefits of gas as an integrated system. So the gas will optimize other generators on the power system, run them more effectively, more cost effectively, will allow for more renewables, cheap renewables to come onto the power system. So in itself, gas may be a more expensive source, but it enables more cheaper capacity. So the end user will see the results and the benefits of that reduced tariff at the end of the day.